My dear students, we continue study the higher mathematics course. My name is Makovkin Sergey Yuryevich. I'm your teacher, your lecturer, and your professor on this course. And so now we repeat the integrals and checking our previous homework. The first task was about find the integral from the x in the power 6 dx. It is a table integral. Of course, it would be x in 7 divided by 7 plus constant big C. The second example, integral dx divided by x in power 5. We rewrite it as integral x in the power minus 5 dx. By the formula, the answer would be x in the power of minus 4 divided by minus 4 plus c, or rewrite it right minus before the fraction. The third example. Integral from the bracket, in the bracket x in 5 minus 4x in cubic plus x minus 1 dx. It may be rewrite as four separated integrals. Integral x in 5 dx minus 4 integral x in cubic dx plus integral x dx minus integral dx. Of course, the answer would be x in power 6 divided by 6 minus 4 x in power 4 divided by 4 plus x in square divided by 2 minus 6 plus c, and we rewrite this fraction and only this second fraction. X in 6 divided by 6 minus x in 4 plus x in square divided by 2 minus 6 plus c. The fourth example, integral from the bracket in the bracket x in cubic divided by 3 plus 3 divided by x in cubic dx. We rewrite it as two separated integrals, 1 by 3 integral x in 3 in cubic dx plus 3 integral x in power minus 3 dx. Of course, the answer would be x in 4 divided by 12 minus 3 divided by 2, x in minus 2 plus constant, or we rewrite it as x in 4 divided by 12 minus 3 divided by 2, x in square plus constant. Example number 5, integral from the fraction in numerator the bracket x multiply root from x minus 3 the bracket in square divided by x in cubic dx. We open the bracket in the numerator. It would be integral from the fraction in the numerator x in cubic minus 6x multiply root from x minus 9 divided in denominator x in cubic. We rewrite the x, of course. We rewrite it as x root from x as in power. In numerator we have x in cubic minus 6x in the power 3 by 2 minus 9 divided by x in cubic. We divided all the all the member in numerator divided by denominator, and we get three separated integrals as integral dx minus 6 integral from the x in the power minus 3 by 2 dx minus 9 and integral from the x in the power minus 3 dx. And we get answer the first x minus 6 x in power minus 1/2 divided by minus 1/2 minus 9 x in the power minus 2 divided by minus 2 plus constant, and we rewrite it in the normal form: x plus 12 divided by square root of x plus 9 divided by 2x and square plus constant. Example number 6. Integral from the x and square multiply the bracket in the bracket 1 plus 2x dx. We open the bracket and rewrite it as integral from the bracket x and square plus 2x and cubic dx. Then we rewrite as two separated integrals. First integral x and square dx plus 2 integral x and cubic dx, and get the answer. I miss this step. We get x and cubic divided by 3 plus x and 4 divided by 2 plus constant. Number 7, from your homework, integral e in power minus 4x dx. We need to make here moving under the differential sign. So here we see e in power minus 4x. We need to create the same expression, the same value under the differential sign. We need to construct d from minus 4x, and to get the 1 here before the integral, we need to divide it for minus 4, or multiply 1 divided by minus 4. And here we can rechange the variables. Minus 4x we can change for new variables, for example t, and we get e in power minus 4x divided by minus 4. Number 8, it is a table integrals. Integrals from the dx divided by square root under root 25 minus 6 in square. We write it as 5 in square minus 6 in square, and the table answer, it will be arcsinus from the x divided by 5 plus constant. Example number 9. Integral from the e in power x plus e in power minus 2x. We write as two separated integrals. First, e in power x dx. We will get the answer, of course, e in power x. And the second, e from the minus 2x dx. This is the second integral, so methodic as the same as in the 7th example. Of course, we'll get here minus e in power minus 2x divided by 2 plus constant. Number 10, integral dx divided by cosinus in square from the 5x. We need to construct d from the 5x as moving under the differential sign methodic, and of course we'll get here 1 by 5 d from the 5x, and the table integral here, integral from the cosinus in square of some expression, it would be the tangent from this expression. Number 11, integral dx divided x in square minus 16. We rewrite it as dx divided x in square minus 4 in square. And the table construction, the table integral, here it would be a logarithm from the x minus this value divided by x plus this value, the absolute value, and 1 divided by 2 and divided by this variable. So the final answer would be 1 divided by 8, a logarithm from the absolute value, and the fraction x minus 4 divided by x plus 4 plus constant. And now we begin new topic of the finding and calculating the integrals. The methodic call it the replacing variable. So let's investigate the first example. Integral x dx divided by square root from the x in square plus 1. We introduce new variable, for example t, and t let will be equal x in square plus 1. So we find the t, and we need to find the dt value, differential from the t. Of course, differential from t would be 2x multiplied dx. And we make a rechange or replacing variables. Here we see x dx. X dx, it would be dt divided by 2, and we need to multiply 2, that this integral would be equal this. And so 2x dx, it would be of course dt, and t or 2 in the denominator, and the square x square root from the x square plus 1, it would be square root from the t. So we rewrite this integral, and we write it, it would be 1 by t, integral from the t in the power minus 1 half dt. We calculate this integral, it would be 1 by 2 multiplied fraction 2 in the power of half divided by 1 half plus constant. And here we need to make the inverse replacing variables from the t to the x. So we remember that t, it is of course, no, here we get t in the power 1 half, or in other words, square root from the t. And we remember that t, it is x in square plus 1. And so we write the final answer. The second example, integral from the x multiply bracket in the bracket x in square minus 1 and the bracket in the cubic power dx. We take a new variable t that equal x in square minus 1. We find the dt value, it is of course 2x dx, and so we make a change. Here we get 2x by dx, it would be t, and it would be dt, and here we get t in cubic. So here I write this. It would be integral t in cubic dt divided by t by 2. We find this integral in the terms of the t. It would be t in 4 divided by 8. And we make inverse rechanging. We change t for to the x expression. And it would be 1 by 8, x in square minus 1 in the power 4 plus constant. Number 3 example. Integral in the numerator x in square dx divided by denominator x in cubic plus 1. We make a rechanging t, let t would be equal x in cubic plus 1. We find dt, it would be 3x in square dx, of course, and we rewrite it in a new form. So we get integral dt divided by 3t. We know this answer. The integral, it would be 1 by 3 logarithm from the absolute value from 3, from t. And we write, we make an inverse rechanging, it will be 1 by 3 logarithm, and the t is equal x in cubic plus 1, and write a constant. Okay, example number 4. Integral e in power, the expression in the power x plus x squared. This e in power multiply on the bracket, in the bracket 1 plus 2x dx. We make a changing x, let x plus x squared would be equal t. We find the t, it would be 1 plus 2x dx. And so this value 1 plus 2x dx, it is called dt, and this x plus x squared, it called t. So we get e in power t multiply dt. The answer would be e in power t plus c, and we change the variables. For previous value, it would be e in power x plus x squared plus constant. Number 5. Integral from the cosinus from the 4x and cosinus in the power of 5 multiply sinus from the 4x. The new variables, let t equal cosinus from the 4x, we find dt. dt would be minus 4 multiply sinus from the 4x dx. And we rewrite here. So cosinus in 5, 4x multiply sinus 4x. And here we create minus 4x under the differential sign. And we need to divide by minus 4. So a new form of this integral would be integral t in 5 sinus 4x d from 4x. It would be dt, and we find the answer. It would be t the power minus t in power 6 divided by 6. Don't forget this minus 4 plus constant. We calculate that in denominator it would be minus 1 by 24 t in power 6 plus constant, and we return the previous value. It would be minus 1 by 24 cosinus in the power 6 from the 4x plus c. That's all. Example number 6. Integral from the e in power minus x divided 1 plus e in power minus x dx. Here we need to take new variable t that equal denominator 1 plus e in power minus x. We find dt. It would be minus e in power minus 6 dx, and we rewrite it. We put new minus to create that minus e in power minus 6 dx equal dt. And so we write that it would be equal minus integral dt divided by t. The answer of this integral would be minus logarithm from the absolute value from the t, and we return the t value. The final answer would be minus logarithm from the absolute value 1 plus e in power minus 6 plus constant. Number 7. E in power numerator. E in power tangent from the 3x divided by cosinus in square from the 3x. The changing here, let t would be equal tangent from 3x. Then we need to find the dt value. Dt, this derivative from the tangent, it would be 1 divided by cosinus in square from the 3x multiply 3 dx. And we rewrite it. In the here we need to we get a 3, and so we need divide by 3 in this integral due to this form must be equal to the initial form. And so it cast to the e in power t divided by 3 dt. Of course, the answer would be 1 by 3 e in power t plus constant, and we return from the t variables to the x variables. Now the final answer would be 1 by 3 e in power tangent from the 3x plus constant. Number 8. Integral from the dx divided by in denominator x multiply square root 1 minus logarithm square x. The correct changing let t equal logarithm x. The easy way to find dt, the differential, dt would be dx divided by x, so we can rewrite the initial integral as dt divided by square root 1 minus t in square. The correct answer, it would be arcsinus from the t plus constant, and we change initial variables. It would be arcsinus from the logarithm x plus constant. Example number 8. Integral from the e in power minus 1 divided by x in square. Here we take a new variable t that equal minus 1 divided by x. We find that dt, differential, differential would be equal dx divided by x in square. And the easy way to rewrite it, it would be equal integral e in power t dt. The answer would be in power t plus constant, and we return initial variables. It would be in power minus 1 by x plus constant. Example number 10. Integral from the x in square dx divided by cosinus in square from the x in cubic. The best way x in cubic called the t new variable. We find the dt differential would be equal 3x in square dx. Here we get a new number 3, so we need to divide by 3. The new integral form would be 3x in square dx. 3x in square dx equal dt in the numerator, and in denominator would be 3 cosinus in square from x in cubic called t. So in denominator 3 cosinus in square t. The answer of this table integral, it would 1 by 3 tangent from the t plus constant, and of course we reverse the variable 1 by 3 tangent from the x in cubic plus c. Example number 11. It is the same example as the fifth example. Integral cosinus x multiply sinus x in cubic dx. Let t equal sinus x. Dt would be cosinus x dx, and cosinus x dx dt. Sinus x in cubic would be t in cubic, and we find the integral in the terms of t. The answer would be t in 4 divided by 4, and change back sinus x in the power 4 divided by 4 plus c. Number 12. Integral from the e in power x multiply sinus from the e in power x dx. Of course, e in power x, let called t new variable. Dt would be e in power x dx. E in power x dx would be called dt. Here is dt. And sinus from the t. Integral from the sinus would be cosinus or minus cosinus, of course. And the final answer minus cosinus from the ex plus constant. the last integral for today, number 13. Integral from the tangent from the 2x dx. Tangent we rewrite as sinus 2x divided by cosinus 2x dx. Okay. New variable t that is equal cosinus 2x. We find dt differential as minus sinus 2x multiplied 2 dx. We find here sign minus and number 2. So we need to divide this integral form to the minus 2. So we have integral minus 2 sinus 2x dx, but minus 2 sinus 2x dx it is dt in the numerator, minus 2 cosinus 2x it is the t in the denominator. So we get minus 1/2 integral dt divided by t. Of course, the answer would be minus 1/2 logarithm from the absolute value of t plus constant. And we remember that t it is equal cosinus 2x. The final answer would be minus 1/2 logarithm from the absolute value cosinus 2x plus constant. That is a new topic for today for you. And the homework, these examples of these topics. The first, integral 2x multiply the bracket x in square plus 5, the bracket in power 7 dx. Number 2, integral x in cubic multiply square root 1 plus x in 4 dx. And the third, integral sinus from the square root of x divided by square root of x dx. Number 4, integral e in the power x in cubic plus x in square minus x plus 1 multiply the bracket 3x in square plus 2x minus 1 dx. Number 5, integral 5x dx divided by 1 plus x in 4. Number 6, integral from the bracket in the numerator 4 minus logarithm x, this bracket in square divided by x dx. Number 7, 2 in the power x in the power 3 multiply x in square dx. Number 8, integral sinus x dx in the numerator divided by denominator square root 1 plus cosinus in square x. Number 8, integral cosinus in 5x multiply sinus x dx. Number 10, integral dx and in the denominator x multiplies sinus from the logarithm x and the sinus in square. And the last 11 example, integral dx in the denominator 1 plus x in square multiplies square root 1 minus arctangent x in square. That's your homework for this lesson. Thank you for your attention, dear students, and have a good day today.